for numbers 76 through 90. So these ones say describe, compute, and or use the rate of change or slope of a line. So it sounds like it's going to be all about slopes and rate of change. So let's see what we have. Which of the following situations represents a linear relationship? Okay, linear means the same change happens every single year. So it says a radioactive substance loses half of its mass every 12 years. Okay, that's called an exponential because you're multiplying it by half every 12 years. That's not going to work. The cost of living increased in a certain area by 3% each year. Okay, again, that's not a linear change either, because what's going on there is 3% of the cost is a different amount every year, right? How about this one? 5 pounds every month on her diet. That's -5, -5, -5, -5 every month. Right? That is a linear relationship. This is what you want to see. Losing the same amount every so often, adding the same amount every so often, where you're not multiplying it or anything. You're just saying it's going to be -5, -5, -5 over and over again, as opposed to these, which involve multiplication and exponential, right? Volumes is something cubical, right? Like that would be the length times the width times the height of that box. And if you change those, you're multiplying 3 separate things. That's totally not linear. This is your answer, D. You're looking for the one that you could produce a very simple pattern like this. So it says a pizza buffet has prepared 18 pizzas to place on the line at the beginning of lunch at 11 a.m. The equation y equals 14x plus 18 can be used to describe the total number of pizzas that have been placed out on the buffet line, where x represents every 9 minutes after 11 a.m. Which statement best describes the rate of change in the number of pizzas set out on the buffet? Okay, so let's see what happens. Alright, so we're saying that if we use this equation, that's going to give us the total number of pizzas that are out on the buffet line. Okay, and then it says where x represents 9 minutes after 11 a.m. So let's just do a few examples there. Right, so what if x equals 1? So we would say, well, y equals 14 times 1 plus 18. And that means after 1, which is 9 minutes, right, because x is every 9 minutes. So when x is 1, what we're saying is that that's 1 9-minute increment afterward. So like at 11:09. So that is going to be 32. So what if x is 2? That means after 18 minutes, or a second set of 9 minutes. That would be 14 times 2 plus 18. So adding 14 times 2, that's 28 plus 18. 28 plus 18 is 46. And let's just do it one more time for x equals 3. That would be 27 minutes, or yet another 9 minutes. 14 times 3 plus 18. And that equals 60. So you can see what we're having happen here is every 9 minutes it goes up by 14. So it says every 18 minutes 38 more pizzas were set out on the buffet. No, because that would mean that every 9 minutes it would be 19 pizzas. So this one says every 9 is 19. Well, we know that every 9 is actually 14, right? We're adding 14 every 9. So that makes this one no good either, right? Because it says every 9 there's 24 more, right? That's not true, right? We're looking for every 9 is 14. Well, how about every 18 is 14? No, because every 9 is 14. No good. So we're left with this one. How does that make any sense? Every 18 is 28. Well, think about it. If we made this 9 by dividing by 2, we'd make this 14 by dividing by 2. It's B. So So what you're trying to indicate is which one of those says a rate of change that says every 9 minutes is 14 pizzas, while the same thing is saying every 18 minutes is 28. Okay, number 78. It says Robert is making a map for geography. In order to draw the map, he must create a scale converting the measured inches on the map to actual miles. Okay, so we have inches and miles. Use the table above to identify the scale he used for his map. Okay, so if we look at it like this, we say 1 1/4 inch is the same as 45. Well, we could probably do a proportion. How about that? 1 1/4 inch is 45. Well, how about this one? If we go up from 1 1/4 to 1 1/2, that's a gain of 1/4 inch, and we went up 9 miles. So if 1/4 of an inch is 9 miles, and so it's not C, right? Because 1/4 of an inch is 9, not 1 inch. But think about it, if you multiplied it by 4, that would be 1 inch. And if you multiplied this by 4, it would be 36. The answer is A. Number 79 says, write an equation in slope-intercept form for the line that passes through 3, 7, and 7, 4. Okay, this is going to take a little bit of work. But the first thing you want to do is find a slope. So let's do that. One thing that's nice is if we know how to do that, looking at A, B, C, and D, we have 3 of the 4 things have different slopes. So that might actually help us out a lot. So the first thing we want to do is with our 2 points, 3, 7, and 7, 4, we'll do the slope formula, x1, y1, x2, y2. Slope formula says y2 minus y1, so 4 minus 7 over x2 minus x1, 7 minus 3. 4 minus 7 is -3, 7 minus 3 is 4. So our slope is -3 over 4, which means we can eliminate C and B. So then how do we solve this to figure out what the y-intercept is so that we know whether it's A or D? Okay, well with this slope, and we can choose, like we know we're going to write an equation that looks like this. And we know that M is now -3 over 4. So let's pick one of our coordinate points. Let's just pick 3, 7. And we'll call that an example x and y. So I'm going to use this generic equation to help figure out what B is by taking this and the slope and putting it in this problem. So y would be 7. The slope is -3 over 4. And x is 3 plus B, whatever it is. So I look at this as now -9 over 4, so I got 7 equals -9 over 4 plus B. And I'm going to add 9 over 4 to both sides and cancel that to help me figure out what B is. So 7 is the same as 28 over 4 plus 9 over 4. Together is 37 over 4. So our answer is A. See, when you go to take a whole number and add a fraction to it like we did right here, this is 7 over 1, but if we make it so that it's a common denominator over 4, it would be 28 over 4. So when we add 9 to it, it's 37 over 4. Of course, you could always use the calculator and just type in 7 plus 9 over 4, and you'll get this as an answer. Okay, let's look at number 80. It says find the x and y intercepts of -x plus 2y equals 8. This is perfectly set up for that, because if you want to find intercepts, all you do is treat it like the other variable is 0. So for example, if I want to find the x-intercept, I pretend like the y part is 0, and I just solve it like this. The x-intercept, -x equals 8, as if the whole y part wasn't even there, because y would be 0 in this case. So x equals -8 for an intercept. I do the same thing for the y-intercept. I treat it as if the entire x term wasn't there, because it would be a 0. So really the problem is 2y equals 8, y equals 4. So we need x-intercept -8 and y-intercept 4. D is our answer. Alright, we got a big problem here. It says Jim drove for several hours recording the distance he had traveled in miles. The graph and data shows the rates of change. Okay, so we got that chart, and then we got 4 graphs to look at. So let's see if we can keep those all on the screen here. Okay, so what do I see? I see after 1 hour he went 50, and then after 4 he went 220, and then after 6 hours he had gone 300. So we want to figure out which one of these is the graph of this data and to show the rates of change. So let's take a look at this. So at 1 is 50, at 4 was 220. See, this is incorrect. See this right here? Incorrect, because 4 is supposed to be at 220, not at 200. So A is incorrect. 1 at 50. This is backwards, right? Look, it's not miles over hours. Like, look at the scale of the hours. This is no good. 1 is at 50. 4 is at 220. That seems good so far. Let's see if the other one is correct. 1 is at 50. 4 is at 220. So we're okay there so far. Okay, so then what else do we have? Let's make sure the other ones are graphed correctly. 6 at 300. That's okay. 6 at 300 is okay. 7's at 320. Okay. And finally 10, which will be out here at 500. Okay, here's our trouble right here, right? Well, kind of. I think it'll still be okay. 10 and a 500 out here. But what they wanted was the rate of change. How much did it go up and how much did it go over? See, this one went up 170 and over 3. Up 80 and over 2. Up 20 over 1. See, those are rates of change. This is not a rate of change. 220 and 4, that's a coordinate point of that point. Same with 306, right? That's not a good rate of change. So your answer to this is definitely B, because it's actually showing the differences between one point and the other, which is what you wanted. Right? What we're looking for is not only are the points graphed correctly, they weren't in A and C. So in B and D, it becomes, well, are they actually showing the rates of change, the differences? So this is the difference in Y, and this is the difference in X. That's a rate of change. This is not a rate of change. Okay, number 82 says find the slope of the line. I think you guys could do that, rise over run. This is an easy one by comparison. Just start here, count up and over to the other one, up 2 over 3, B. Number 83 says Tara creates a budget for weekly expenses. The graph shows how much money is in the account at different times. Find the slope of the line, then tell what rate the slope represents. Okay. Well, let's find her slope. I mean, we went down 2,000. Sorry, geez, no, down 400 and right 8. So 400 over 8 is our slope. If you divide it, that's 50. And remember, we went down, so it's negative. Negative 50. So what are we talking about here? Well, this was dollars, and this was weeks. So she's losing $50 per week. So it says the slope is negative 50. The slope means that the amount of money in the account is decreasing at a rate of $50 every week. Well, that sounds awful good. Okay, so why would it be every 2 weeks? We did it per week. So no good, not every 2 weeks. The slope is negative 0.02. The slope is 50. Well, again, it was negative 50. It's not, look at this thing, it's going down, right? The slope means the amount of money in the account is increasing at 50. Definitely not, it's going down. So it is A. Alright, so if we read through all of those, right, none of them make any sense except for A. But if you calculate the slope, that's exactly what you find out, that it's losing $50 per week. Okay, find the X and Y intercepts, number 84. Okay, looking at a graph, just asking you if you know what an X and Y intercept is. So an X intercept is where the graph touches the X axis. So X intercept is 10. Y intercept is where it touches the Y axis. Y intercept is 5. And answer is D. Okay, number 85. It says, tell whether the function y equals 5x minus 3 is linear. If so, graph the function. Okay, it's definitely linear because there's no exponent on the x, and I mean that's the basic format of a linear equation, right? Y equals mx plus b. Most definitely a linear equation. Alright, I see a negative 3 as a y-intercept, so our graph better be touching the y-axis at negative 3. So point A is okay there, graph A. Here's negative 3 on C, no good. We know it's a function, so it's not D. What about B? Y-intercept at negative 3, no good. So it has to be A. Just in case, so you see, if you see the y-intercept at negative 3, this slope says up 5 and over 1. 1, 2, 3, 4, 5, and over 1 would be another point right there. So if you can't eliminate it all by just the y-intercept, as we did in this problem, the slope would tell you to go up 5 and over 1. So it has to fit this pattern. Alright, let's move down to 86. This one's asking you to analyze, interpret data from a scatter plot. Lots of scatter plot stuff on the Keystone. So it says the graph shows a line of best fit for the data collected on the amount of water bills in relation to the number of gallons of water used. What is the equation of the line of best fit? Okay, we want to watch out for stuff like number of gallons in thousands. So when we're counting, we're not counting over 1, we're counting over 1,000. The amount of bills in dollars, so we can just read these as they are. So the first thing I would look at is, what's the y-intercept indicate? Well, the y-intercept is right here. So somewhere around like 13 or so. But as you can see, in each one of these problems, they all have the same y-intercept of 49 over 4. So we're not going to be able to eliminate anything out of the y-intercept, so our only other recourse is the slope. So let's see if we can figure out a good slope here. We need to find 2 points that we can tell what they are really easily. How about right here and right here? Easy to count. So it would be up 1, or in this case, like we went up this way and over this way. That's how we're going to count a slope. Rise and run. Right? But the rise here, how much did we go up? We went up from 21 to 28. We went up 7. And then we're going over 1,000, 2,000, 3,000, 4,000. Right? So remember, you're going right, not 4, but 4,000, because this is in gallons in the thousands. So our slope is 7 over 4,000. So it means our graph is B. Right? 7 over 4,000. Another way to look at it, you could eliminate C and D. Maybe you guys already know why. Maybe you did it already. You can eliminate C and D because these indicate downward slopes, right? This is an uphill line. So you should be able to eliminate C and D because of these negative slopes. So you're either A or B, and then we just showed how you figure out it's B. Sounds like the same kind of thing. Let's take a look at this one. Okay, the graph shows a line of best fit, such and such. Let's see. Okay, so again, we have numbers in the thousands here, right? So when we look at the y-axis, we got to remember this is not 1, it's 1,000. So I see a y-intercept right there, which means my y-intercept is 1,000. So I better have plus 1,000 on the end of my equation, which means I can eliminate B and C. So then let's find another point that we can count. How about the very next one right there? How do I get from here to here? Okay, again, I didn't go up 1, I went up 1,000 and over 1 inch. So my slope is 1,000 also. It's D, right? So A, they want you to they put A in here as an option in case you counted it as up 1 over 1. But remember, it's up 1,000 and over 1. So it's actually D. Okay, which of the following equations represents the line that is drawn below? So it's the same 3 problems over and over again. Just can we read the graph? Okay, so this is pieces of candy and minutes. So we don't have to worry about any different numbers here. It's just the numbers that we see here. So I look at the graph and I see it's a y-intercept right here, somewhere between 0 and 3, like maybe 1.5. And I look over here and my options are 1.4. So okay, that makes sense, some kind of 1.4, but it's a positive 1.4, right? So the graph would have a plus 1.4 on the end. So I can eliminate B and C because they have negative y-intercepts. So then the question is this is an uphill line, right? So the slope, regardless of what it is, should be positive. So I look at A and I look at D and I say D has a negative slope. No good. It has to be A. Okay, let's go to number 89. So 89 says the daily high temperatures in degrees Fahrenheit of a town are recorded for 1 year. The median temperature is 62. The interquartile range of high temperatures is 32. What is most likely to be true? Okay, this requires you to think of something like a box and whisker plot. That's when you start hearing about interquartile range and so on. So what we see is on a graph, right, this box and whisker plot would be drawn in. It might look something like this. This is 62, and it says that this interquartile range, the length of the box, so to speak, is 32, and then it goes off like this. And we don't have info about that data. But remember that this is like the 25% cutoff line. The median, of course, is 50%, and then this end is 75%. Let me bring that down so you can see that. Sorry about that. So this is just a generic box and whisker plot where the median is 62, and we know the interquartile range is 32. So we said the lowest 25% would be one end of that, and the highest would be 75%. So it says approximately, let's see what's true then. It says approximately 25% of the days had a high temperature less than 30. Okay, I don't know if we can come up with that, right? Because if we know the range, I don't know that we know that is true. Approximately 25% of the days had a high temperature less than 62. No, because 62 is the middle line, so it's not this one. C says approximately 50% of the days had a high temperature less than that. That would be true, right? Because the median is there.
Please report to the guidance office. Rachel Roscoe and Jamaris Field, please report to the guidance office.
So let's look at number 90. It says, what is the range of the following set of numbers? Range is from lowest to highest. So the lowest is 23. The highest is 46. So if you subtract them, the distance is 23. Right? 46 minus 23. Range is 23. Let's do number 91 while we're at it too. Actually, you know what? I'm going to stop there. We'll stop at number 90, and we'll pick up the next video with number 91.